We work with huge companies like Mars to Heineken to, you name it, big company, PepsiCo, across the world, building everything from a Kickstarter, shipping thousands and thousands of units all over the world with that, and building up a company and building indoor positioning systems. But generally, I take the software from zero to product. Back in the days, let's say in the craze of 2017-18, when the self-driving craze was at its height, the sensors that could drive safely just wasn't around.
Moving from next 5 years, 10 years, where do you see the future and realization of autonomous driving in general? Do we have robotaxis everywhere in our towns or what?
We can get much better asset utilization, which means we can produce fewer trucks in the future, but move the same amount of goods, just letting software and AI work for us.
Hi everyone, welcome to our podcast, BetterTech. Today we have a very, very interesting topic, that is autonomous driving in transportation with industry expert, founding engineer, and senior vice president of Einride. Welcome, Thomas, to our podcast.
Thank you, and great to be here. Thanks for having me.
Yeah, you're welcome. So, by the way, just one question from my curiosity, the name of your company, Einride, it seems to be like the German name. Can you explain it?
Yeah, so a lot of people think it's German, but it's actually an Old Norse name. It comes from the Vikings, basically. So it's another name for the god of thunder. It means the one who rides alone. And the company is building on that, the god of thunder sort of likeness. And we also like the name, of course, as it sort of ties in electric and movement.
That's great, Shahzad. Good to know. So tell us something about yourself and a little bit about Einride for our audience.
Yeah, so myself, I'm a software guy, and I've founded a bunch of different startups in different technology fields, and I've been based here in Sweden, in Gothenburg and in Stockholm, as well as in the Bay Area, and building everything from a Kickstarter, shipping thousands and thousands of units all over the world with that, and building up a company and building indoor positioning systems. But generally, I take the software from zero to product. It's been the deal. But Einride is the thing I've been working the longest on so far. And obviously, it's down to the technology being so much fun and the mission being really, really great.
Oh, that's great. So, as I understand, Einride is doing a lot of work in AI and machine learning. So tell us how you integrate AI into development for autonomous driving technology in transportation.
Yeah. So maybe to set the frame of what the company does to begin with, is we're helping large companies to transition from analog, diesel, manual freight to digital, electric, autonomous freight. And why I say transition is because it's not simply just switching out the trucks. A lot more goes into it. You need to have a different business model that ties together with technology. You need to change ways of working, and you need to tie in software everywhere. And a lot of the companies in our industry, they've been used to pen and papers and phones over many, many years. And in order for autonomous vehicles to have somebody to speak to, a whole lot of the digitization and process remaking needs to happen. So what we do is to enable software to get data out of all the different parts of the whole ecosystem in order to optimize the usage of all the resources. Because when you get to electric, what is hard is that you have 3 different anxieties. You have range anxiety that most people knows about. You have charger anxiety. Will there be a charger there for me when I need it? Yeah. And you have a cost anxiety that there is a high upfront cost to do the changeover. So we need to help the industry with this and to basically get over to a more sustainable freight solution that is also more cost efficient. That's what the company is for. And we work with huge companies like Mars to Heineken to you name it, big company, PepsiCo, across the world. And we have deployments in both Western Europe as well as the Middle East and in North America. And we have the largest heavy electric fleet in the world. But the point with all that is to really get data out of all these parts so we can make a system that learns how to use all this complex data that is just too complex for non-machine learning algorithms to handle in order to move freight in an efficient enough way for the economics to make sense.
Perfect. And so how does that AI or machine learning or data that we collect, it helps you in achieving, let's say, efficiency? So I think I have two topics that I thought that how does then AI helps, let's say, achieving efficiency? You mentioned fuel efficiency, and the second will be more about safety concerns in autonomous driving. So
yes. So obviously huge topics, but like I said, we have the biggest fleet of electric trucks. Machine learning there is critical in particular when it comes to energy prediction. So any given day, you have this huge truck that is very, very heavy. And by doing these integrations, you get some weight data, you get a specific configuration, you know what trailer it's using, etc. You know the weather outside, so you know the temperature, and there's millions of these different things that you can couple in over time. But obviously here, that's a lot of different data sources. And that's where just complexity goes to the roof. And doing energy prediction is one of the places in particular where we have machine learning models that figures out exactly how far a given truck can go a given day, which means then we can plan charging infrastructure to be available and book slots months in advance, and hence reaching a high utilization rate of our chargers. And at the chargers themselves, we can also figure out exactly how much energy the truck will need. So let's say we have 5 trucks at a charger, we can allocate the available energy from the grid to just one truck. That makes the most sense for the optimizer.
Right.
And this is all down to that energy prediction machine learning algorithm. The other end of it is we also have separate models as well as for like classical things like predictive maintenance, which has been around forever, but also battery degradation models. Because over time we get a difference in performance, and if we can't model that difference both when we charge and also when we discharge, so use it, if we can model that correctly, that's a crucial part of the energy predictions. But that actually, it's a multitude of model that goes into doing that. So that's on that. And I was going to go over to the autonomous end as well, because that's obviously where it's sort of everywhere. Because if we look at the hardest topic in itself is safe perception. Because typically with algorithms, you know well how they work, but the world is just too complicated to use classical algorithms. So typically you need to mix both some classical algorithms, which have some predictability, with machine learning algorithms, which have much higher performance, but also high complexity, which means validation is harder and how to think about safety for them. But that's where a lot has happened in the latest, and I think we'll dig into a lot of that. But basically these days, you have machine learning model in different ways in basically all the domains of autonomous vehicles, from motion planning to prediction to perception. And just if you want the best performance, that's where you go pretty soon. The classical algorithms doesn't take you that far.
That's interesting. And then you put explainability together with the classical model. And maybe a little bit of deviation from this question. This is about like, okay, when you implement, what kind of challenges do you see? Can you elaborate a little bit more? Because now you're dealing with the, multiple types of sensors, dynamic environments, and huge amount of data, real-time decision making. So how Einride, your algorithms are actually working in that and making sure that, things are running perfectly in that sense.
Yeah, no, it's a huge topic. But some important things is you need validation is sort of everything. Because in the end, if you want to go on a highway and be able to say that you are sure that it's going to be safe, you need to both have built great algorithms and have closely monitored performance of how those models perform. And you need to have a well-functioning data factory so that you can have a continuous improvement loop going on, exactly like all other software. But that is, of course, very, very hard, because it all goes down to how do you make sure your labeling is consistent, and how do you weigh that data so you input the right types into the right places, basically, so you get the right distribution and all these things. And then when you have all that, that's when you get to actual validation, where you compare your ground truth to the performance of your perception algorithms. And when it comes to different modalities, that's also where you can, in some ways, use them to reference check each other. So your LiDAR perception can, in some ways, be you can use them as a separate source of information for some things to your other sources, which means you can sort of get a voting in between them. But it's also true that there is both like a early fusion and a late diffusion. And with early fusion, basically means you take the raw data and you let the algorithm figure out that complexity. While with the late fusion, then you do know a bit more about the data before you actually input it. But then you do also lose the complexity, but you make it more controllable. And typically, when you build a safe perception system, you combine a bit of everything when building something like that out.
Oh, interesting. And now that I think we are getting a lot more in the tech detail, but I love it. I think this is really, really very interesting and insightful thing. Now, if we compare, let's say, algorithm and technology, let's talk about, let's say we have sensors, right? And how did you see the sensors, the quality, the cost, that has, let's say, changed from past 5 years until today? And it's also very important for me to understand from, because in the other digital industry, online data, you just have algorithm and you can use whatever is the best thing available. But if I'm not wrong, automotive industry has a bit of long cycle where you have this design until production. So you have already decided about sensor, and next day you find there is a nicer, cheaper, faster sensor. So can you discuss a little bit about how about the hardware side of the technology together with the new trend?
One of the complexities in building a company in automated driving is that you always have this fight, let's say, inside the company, where you have software engineers that have very, very fast cycles, and you have hardware engineers which think in slow cycles, which makes sense from the different domains, because hardware, if you make an error and you get a recall, it's basically end of days, and software is just launch another one. So it's very different mindsets, and you need to have them live together. But you bring up a good point that back in the days, let's say in the craze of 2017-18, when the self-driving craze was at its height, the sensors that could drive safely just wasn't around. They didn't have the safety certifications, and what that in effect means is that unknown errors were happening now and then, and those were just random. And when you get to these, let's call them safety certified system, you don't actually get these random errors. The errors that do happen will have diagnostics, and they will have been seen before. So you know consistently how your sensors perform. And those sensors exist these days, where you actually get guarantees on that. And that means you can build a safe system on top of it. And you can, to some extent, solve some of those things with redundancies, of course, having multiple sensors doing the same things and working in tandem. But if you have stable sensors, it's significantly easier to prove your safety case, because you can always otherwise get these weird errors that just wasn't seen.
So if I take, let's say, this one question a little bit further, now moving from next 5 years, 10 years, where do you see the future and realization of autonomous driving in different scenarios? Journal, let's say, freight, you mentioned you're generally working, but also, let's say, in general, will we have robotaxis everywhere in our town or what?
I think some people feel that autonomy sort of was supposed to happen, but didn't. But if you think about it, if you look inside of factories, we've had autonomous electric vehicles for the last 40 years. And these days, they're doing everything inside factories. So what we're doing, in our case in particular, where we're looking at heavy trucks, our strategy is going from slow speeds into faster speeds over time, and thereby as our capabilities and data improves, we can just do more and more. But in simplicity, you could say that we're just moving those things that are indoors to outdoors, and that's all it is. But obviously, as soon as you go on public roads, safety, type approval, regulation, and especially severity of anything going wrong is much, much, much harder. And that is what we're struggling with. But yeah, in that it is coming into a lot of industries. We're already seeing mature deployments in mining. You can look in the streets of San Francisco where you're seeing Waymo's doing 100,000 rides a week. That has never existed before, and these are crazy numbers. So I think it just tells you that maturity is coming and things are improving quickly. So I think there was a view some time ago that autonomy would just come overnight and just be ubiquitous everywhere. But I think like with all other automation, typically you find something in particular to automate first, and you take care of that. You get it to work really, really well with a great business case. And then over time, you take on more and more and more, and automation spreads. And we're going to have a mix of human-driven vehicles and automated-driven vehicles over a long time. But I think there are a lot of deployments going to actual commercial use cases where you're moving goods for customers. There's still some way for it to get to the scale of 1,000 and beyond. But when you get there, economics are great, and obviously for a sustainability point of view, robots are fairly good at asset utilization. Let's say so. That will just drive itself. The unit economics is just too great.
That's great. So this is like the one part of the story, which is about generally regulations, and then also maybe the use cases, right? So for industrial use cases, for business parts, for that is where we already see that it makes a lot of value. Now, another aspect is public skepticism. Again, because it as you mentioned that it was like, oh, there will be overnight some sort of autonomous driving, but there was also a lot of errors or fears with autonomous driving, especially this transition phase. So how do you see that changing from, let's say, 5 years from past until today, and then from today to 5 years from now?
Yeah, I think a funny story on that is we used to get the question all the time. So you'll take drivers' jobs away, and that is horrible and things. But then COVID happened, and pretty soon after that, we just started getting the question, how soon can we have it? And I think for society to work properly, we need lots of automation. We already are working, across factories and other places. We just can't live without it. And we need more in order to keep our way of living and also to live more, sustainably. Because then we can get much better asset utilization, which means we can produce fewer trucks in the future, but move the same amount of goods. Just letting software and AI work for us. And I think that's what we should keep track of. But when we're out there, we're working with unions, we're working with our customers, we're working with municipalities in order to get this technology out there safely. And people want it, and it's needed. So that's why I'm here.
Perfect. So it's like you're optimistic, and I think I know what you mentioned in the very beginning about the quality of sensors, their SLAs, it has improved a lot. So I think it's resonated well to me that they just let a lot of focus. You mentioned sustainability, and I think I also checked from the website of Einride, the commitment of to zero emission, zero waste, and zero death rate, right? So how are these sustainability goals integrated in your technology, but also your business model?
So that's a great question, and a very important one, because in the end, that is why we exist. So one of the important things is we sell this as a service. We sell capacity as a service rather than just selling a truck or selling, a truckload. Because in the end, what our customers care about is moving their things from point A to point B. isn't that what we should be selling in the end? The thing that our customers actually need. Because sometimes today they just call a truck and they send something, and that's why we don't get great utilization. And that's also why the salaries of the drivers sometimes aren't as good as they could have been, because we aren't utilizing our resources in society as efficient as we can. So by having this business model and helping our customers with both the CapEx investments and finding ways of getting great economics to this, that is how we can make the transition easy. That is how we can remove all these CO2 from ever being released, and at the same time delivering great bottom line results for our customers, because they need something that both bring them sustainability as well as great economics. Sure. And that's what we need to provide if we want society to change.
Well, that's good. So in this way, then the customers are also asset light, and their goals are also then met. So you're not really contributing the carbon and another thing in the world, and it's all up to you, and then you got everything control. That's good. I'll just get one step back to, you mentioned data, and you mentioned that, it's not a goal, right? So then you have one of the things that is helping you is also deploying your meters and collecting data and then improving the algorithms. So data privacy and data security, is also one of those big concerns. So how does Einride handle privacy and security for the data?
So being based in the EU, it's very high up here on things we need to care about. But as we have deployed our truck fleets, we get data out of the telematics units there, and we use that to optimize all our freight, and again learn how to predict energy in a very precise way. We're something like 90% precise on energy prediction, which is well beyond what anyone else has in the industry. But that is down to that we integrate our own chargers with our own trucks, with our customers' data, so that we know exactly where the truck should be, what energy it will have, what sort of grid capacity it needs. So we can talk less about the size of the battery and just having the largest possible battery, and rather the most efficient size of battery for the job that needs doing. But back to the question on privacy. As we work with these huge companies, it's something that comes up early in those discussions. When it comes to autonomous vehicle data, we're operating mostly in areas where people don't move that much. Our autonomous deployments are typically between logistics centers and factories, for example, in sparsely populated areas. And we want our vehicles to be boring. We want people to know exactly where it's going to go, because we take those flows which are boring, which humans don't like. We just go back and forth all day, high capacity, high uptime flows, which is perfect for automation. But there's not too many humans in the vicinity, but where it's super important that we anonymize all that data and make sure we have full control of it. And also that testing data, we typically make use of a lot of synthetic data, a lot of simulation. And
then we have my next question.
Yeah.
I want to this next question.
But this kind of comes into it. Being able to make a reproducible data set for improving your system is critical in order to be able to not get regression.
Interesting. Now this brings two more questions from my side. One is really about the synthetic data and maybe it's related also to the simulation, the rollout simulations for testing, because I think you can't test everything on the road and so on. So how do you see, how do you use simulations and synthetic data as of now?
So simulation is typically, like you say, it's like an 80-20 thing. You will never get to replicating reality, but you can get to replicating certain things really, really well. And those things you can make sure that you test in particular ways. And then when we deploy any type of software, any new commit of anything, it runs through a pretty fat simulation pipeline, which tests certain things in certain areas and sees on the results if it should dig in deeper, basically. And then you sort of get these weird 3D graphs, which shows you the types of scenarios which you can't handle, let's say, because you sort of test these spans of variable changes, and you get these fairly advanced graphs, which tells you where the range of function is for the vehicle in a certain situation. And that way you can fairly well know that if you don't go anywhere near those ranges in reality, you're probably going to be fine. And you can also validate that on test track before releasing any version to reality. But on top of that, synthetic data, in particular, where it's really, really hard is when it comes to perception in particular, because there's a lot of great physics testing when it comes to motion planning and testing certain things around prediction and whatnot. But when it comes to making actual LiDAR data and the camera data, there is always a mix of synthetic data and your historic data. And then these days you can create variations of your historic data using Gen AI functionality and create variations that you suspect might have issues in them in order to replicate an error, fix it, and then be able to deploy it.
No, I see. Very interesting. Well, you have been, and by the way, we can, I love this discussion. I had other question about like, okay, what kind of models to go, what will be the technology under it, whether it's the Unreal Engine or so on, but I think I'll stop here for the sake of time. And maybe one last question. You yourself have been, you yourself are a top developer in Sweden. And you're leading different startup hackathons, and you're really into, community. So what advice would you give to software developers as well as startups?
I think one thing that's been immensely important for me is both that in this company we had a very strong mission. Everybody who's coming here, they're here for that mission. Doesn't matter if you're working in sales or if you're working as a developer. And for me, that comes out of software. I think it's great that even when days are tough, you know that you have a reason for being here, which is beyond the company. Because a lot of people in the company would work with this topic outside of Einride or inside. It doesn't really matter in a way. But having that mission, going into interviews, meeting talented people, you get people you just wouldn't get otherwise by having a strong mission. And it also helps yourself day to day, just knowing why you're doing what you're doing. Because in the end, if you're just doing it for money, I don't think you're going to get the best people. And I guess that is one thing that has been immensely important for us throughout the years and will continue to be. And when it comes to technology, I think, there's so many things on building a team and letting yourself be nerdy throughout the years. I guess we started out a long time ago just choosing technologies we loved. And that turned out to be another great way how to get other really, really great people who also love technology, because some of these choices are really, really helpful for getting them. However, there's of course limits to that as well, where you can't just choose the newest and coolest technologies. You need to look at a lot at maintainability, who's behind it, and will it be long-term in these things. And then when it comes to, and so adopting new technologies it's hard in this. When it comes to hardware, I mean, hardware is hard. That is good to know. We need to do it because that's actually another thing that's important to understand, that in the early days of the autonomy industry, people used to just take a truck, put some sensors on it, retrofit it with some compute, and then drive it. And that approach works up until a few tens of trucks. But then you're going to have issues with your hardware, your installations, stuff breaks and whatnot. If you want to go to commercial scale, you're going to need vehicles that are purposely made for autonomy with the right redundancies, with a platform that's built ground up for it. So we've done that in order to remove the cab fully and remove the driver from the vehicle, which is sort of unique. But that takes me to the advice is like, if you don't need to do hardware, don't do hardware. If you really need it, it can become a moat, but it's super, super hard. It's also fun because it's different for a software person. It's really a different feat.
This is a challenge, and that would have been like maybe just a corollary of my question about, how the advice for software engineer who wants to, let's say, enter in the autonomous driving technology and this type of AI, because a lot of other software tech, personally, I'm like kind of feeling like, there is a lot coming with Gen AI, with development of the code, but in some areas of AI, there is still some challenge or a lot of challenge left, right? And
I think it is. It's true. But the autonomy development is going to continue for many decades to come, because if we're going to replace all these vehicles in an efficient way and with the most cost efficient hardware, then it comes down to having great software that can utilize the data you get in a super efficient way, and that is going to be a massive challenge. But if we can pull it off, it means we can produce fewer cars, we can produce fewer trucks, and we can use the ones we have much more efficiently. So coming into this industry, I think it's, like I said, it's always going to be important to have a great mission and a great why. And whenever I've interviewed anybody, I want to know their why. That's my first question. Mm-hmm. Why are you here and what is it you want to do? And I typically don't want to hear, I just want to have my next nice hat or whatever. I want to hear that they want to change the world, be a part of that. And even if you're working on some obscure system, it is still true that you are changing, that obscure system to the better, which is a part of a grander society. And I think it's just a question of mindset on finding that purposeful mission. And people should stick to that principle, because if you don't care about morale and stuff, you can always go work for an online casino or something.
That's really lovely. Great message, and I think very valuable thing for developers. It's not only the technology skills that we are talking. Having your own why is very, very important. And what Thomas, you also mentioned that there are fields there which are challenging, which are still challenging and not so boring, right? So really great you here, Thomas, today, and having this discussion. I appreciate
great thing.
Okay, perfect. So thank you everyone for today's for having us today, and thank you, Thomas. Have a nice day.
Yeah, thank you too.